This is an example of solving a linear programming case. This is part of a system of linear equations and inequalities. This problem is taken from Algebra Trigonometry textbook for 10th grade, page 164, number 5, aircraft problem. So let's meet Mr. Calvin Butterball, and he is a chief mathematician of for Fly-by-Night Aircraft Corp, and he is responsible for mathematical analysis of the manufacturing of the company's two models of plane. So there are two models of planes. The first one is Sopwith Camel, and the second one is a Sopwith Hippo. So he is responsible to plan how many camels and how many hippos should be manufactured per day. So let's start giving the label or the variable for each. So for the units manufactured per day for Sopwith camels, we use C, and for Sopwith hippo, we use H. Okay, so let's go deep into the variables, and these are the variables that we are using. C, number of camels manufactured per day, and the domain must be whole numbers. Whole numbers means that we don't accept negative, of course, since we are talking about production. Whole numbers means that we include zero. Still, we open for a possibility that we don't produce any camel. And of course, if we decide to produce one or more, we only accept integers, right? So the number of camels that we manufactured, we only accept one, two, three. We don't accept any decimals. Okay. And it goes the same with H. The H is number of hippos manufactured per day, and domain also whole numbers. So both of these are the independent variable for this case, since yeah, they have the same level. So number of camels and number of hippos are independent variables. So the dependent variable will be P, the total daily profit. So we are looking for the profit, the highest or the greatest possible profit that we can gain from producing these two models. And here comes the restrictions. Why? Because without restrictions, of course, to gain the most profit, we of course decide to produce as many as possible of these two models, right? But again, in reality, we are restricted. But for this one, for this case, we only be restricted in these two scope: production, shipping, sales, and labor. And let's go first for the production. What is the restriction in production? So the textbook or the problem provide us that there will be no more than 7 hippopotami. No more. It means we can accept less than 7, which is 5, 3, 2, and we can accept we produce 7 hippo. But the production cannot go further from there, so we cannot produce more than 7. It means the language in inequality will be H is less than equals to 7. The next one is no more than 11 camels. It means we can produce 7 camels, we can produce 5 camels, 0 camels, 11 camels, but not 12, not 13. Therefore, the inequality comes like this. So only two inequalities that are being provided for the production perspective. So let's go to the second, shipping. For shipping, there will be no more than 12 planes total can be manufactured per day. 12 planes. It means the total number of hippo and the camels, it cannot be more than 12. It can be 12, it can be 7, it can be 8, but it cannot be more than 12. It means the inequality statement will be the total number of hippo plus the total number of camel is less than equals to 12. Okay, that is how you translate the sentence. The third one is from the sales. The sales regulates us that the number of hippopotami manufactured per day must be no more than twice the number of camels. Again, we are given no more. It means it can be equals to, it can be less than, but it cannot be more than. So the translation will be the number of hippopotami is the age, must be no more, it means less than equals to, then twice, 2 times C. Okay, that is from sales. And the last one is from labor. You must use more than 1,000 man hours of labor per day. So we have to use more than. It means we cannot use less than 1,000. We cannot use exactly 1,000. We must use more than 1,000. But there is another description here is that it takes 100 man hours to manufacture each camel and 200 man hours to manufacture each hippo. So the translation becomes this. So when I produce or manufacture camels, one camels, I will already use 100 man hours. It means if I produce or manufacture two camels, I will use 200 man hours, 100 times 2. So this is the inequality. 100C plus 200H must be more than 1000. Therefore, we have already had all of the restrictions being given, and these are the summary of all restrictions. And from these five, actually, we can still simplify the last one. The last one still involving large number here, and we can simplify it by divide all by 100. So therefore, if we divide them, the result will be C plus 2H greater than 10. So we're ready to go to graph these restrictions and find the feasible region. So let's see how to graph this. Okay, this is all the restrictions that we have acquired so far. And this is the Cartesian that we use. Notice that we only accept positive value for H. This is the H, the hippopotamus, and this is the C for the horizontal line. So only positive values. And then for the placement of the labels, again, since they are both independent variables, it means that you can put C on the horizontal axis or on the vertical axis. It depends on you. Okay, so the H and the C, it can be, it's really up to us. But for now, I will put the H, it's on the vertical since I find that there is a certain uh, inequalities that use the H in regards of something. So the H, it is on the vertical, and so I can see directly the slope here. If I'm using H as the vertical, so for this one, the fourth inequality, the slope will be 2. It will be easier for me. And for the others, it doesn't matter since we are using the x-intercept and y-intercept technique. So let's begin with the first one. H is lesser and equals to 7. Since the H is the vertical, it means this one is a horizontal line, horizontal line on 7, right? So yeah, this blue line. Notice that I start with from here since we don't extend to the negative, okay? But it's not mandatory actually. It's just I want to be uh, consistent with the domain. And then we go directly to the positive value of C. So here is the line first. So I don't want to sheet it. First, let's just draw the line. So the line is H equals 7. And then the second one, the line is C equals 11. It means it is a vertical line at 11 for the values of C. And then the third line, I use the x-intercept and y-intercept technique, or sorry, the h-intercept and the c-intercept technique. I'm sorry, I have to revise that. So the h-intercept is the value of h when c equals 0. It means it's 12 for the h. And c-intercept is also 12. So let's connect both like this. Okay. So yeah, there is I don't use the arrowheads again because of the domain. We only accept positive. And then the fourth, it is h equals to c. Okay, it means the h-intercept is 0, the h-intercept is 0, and the slope is 2. So let's just draw it. Yeah, this is the fourth line. And the fifth line, I'm using another c-intercept and h-intercept technique. So the c-intercept is 10, and the h-intercept is 5. So this is the line. And notice that this is the only dotted lines since there is no equal sign here. Okay, now let's try to shade it. Okay, if we want to shade it first, for the first line here, since it is h, oh sorry, the first line is here, since it's h less than equals to 7, it means the one that being shaded is the area below of the line. Okay, I don't want to show the shade, I just want you to imagine it, it is below the line, so that is, so the area above this line cannot be your visible region. Keep in mind that. And then the next one is C less than equals to 11. It means it is on the left area, sheet on the left area. So actually, we have already had this small this rectangle area from, from these two, okay, from these two lines, the two inequalities, we have this rectangle area. So this is the visible region if we only include these two inequalities. So let's extend to the third line, h plus c less than equals to. So the perspective is from the h, right? Since h is the vertical line, vertical axis, it means I can see from the perspective of h. H is less than equals to. It means the one that we shaded is the area below the line. So this is the line, the purple one, and shade below the line. So actually, I've already had this trapezoid, the trapezoid, almost kind of trapezoid as the visible region. And then extend to this h less than equals to 2c, which is this red line. Since we're using the perspective of h and it is less than, so we shade the area below of it. So now it's getting more like a triangle here, like this one. This is the area of the solution or the visible region. And the last part is C, this one, c plus 2h is greater than 10. From the perspective of h, greater means you shade above it. So after we shade all of it, this is the visible region that we are looking for. This is all the pairs. So all the pairs inside the green one will be all the pairs that satisfy all of these restrictions. For example, if I'm using the pairs 15, 0, if I produce 15 camels, no hippo, it is not an option. Why? Because it will violate the second restriction, since I can only produce less than equals to 11 camels. So rather than you have to check one pair to all of these restrictions, this graph will easily show you all the visible pairs. And now for example, we are accepting 5 camels and 5 hippo. It is around here, right? So we can produce 5 camels and 5 hippos, and it won't violate any restriction here. So the thing is, we have these candidates from all of the pairs inside the visible region to find which one is giving us the greatest possible profit. So let's go to the profit itself. So the book provides us information that for for each camel we will gain profit $300, and for each hippo we will have $200. It means the total profit that we gain in function of the total camels that we produce and the total hippos that we produce is 300C plus 200H. Therefore, originally, conventionally, let's just put all of these pairs inside of the visible region, all of the candidates here, although we are only included integers. So it can be 4,5 or 3,5, 5,7, 5,7 here. Yes, it is 5,6. So all of the candidates here, try to put it into the profit equation, and then you find which pair that will give you the greatest possible value for the profit. Well, it takes time, of course. So the first method that we suggest is this. Let's make an assumption. If the profit is 3,000, okay, if the profit is 3,000, I want to aim profit equals 3,000 exactly. It means if we put it into equation, it becomes 3,000 equals to 300C plus 200H. And this can be drawn. This is a linear, not function. Let's just say this is a linear equation. So you can graph this on this graph, right? And the graph of this equation will be the all the pairs that give the profit equals to 3,000. So let's just graph it. Before we graph it, of course, I need to simplify the equation since it is involving a large number. So I divide all by 10. So this is the equation. So I will use the c-intercept and h-intercept technique also. So the c-intercept will be 10 and the h-intercept will be 15, right? So 15 and 10. So this is the line. This line shows all pairs that will give the profit 3,000 exactly. So actually, if I'm having these pairs from the inside the visible region, it's on that line. I can directly sure it will give us 3,000 profit. Therefore, every pair inside the area in the feasible region, but it is lower than this line, the line of profit 3,000, will give you profit less than 3,000. So all of the pairs inside of this area, let me just give you different color for that part. So inside the feasible region, this light blue region, all the pairs here will give you less than 3,000 profit since it is on in the lower part of the 3,000 line, 3,000 profit line. It means since we are aiming to find the greatest possible value of profit, we cannot take from the light blue region. We have to search further from the dark green area to find which pair will give us the largest possible value because the green area will give you the profit greater than 3,000, of course, greater than $3,000 since this is a 3,000 profit line. So how to find exactly where is the pair that give us the largest one? We use this line. Let me just make it thicker, and then yeah, this line. Let me remind you that this line is a line of 3,000 profit. So it means all the pairs on that line will give you exactly 3,000 profit, and we are aiming to find the largest possible profit inside the feasible region. It means I can use this line as a tester line. It means I can slide it slowly to the right, slowly, and find where is the last pair it touched inside the feasible region. Oh, we have already passed it. So let's see which line, which pair. It seems that this is, yeah, this one. The intersection between the brown line, the vertical brown line, and the purple line. This is the pair that it touched last if I slide it to the right. Why I slide it to the right? Since we are aiming to find the largest possible value. Okay, so it seems it is like it's 11 comma 1, 11 camels and 1 hippos. It seems like that based on the graph, but let's just continue to search it by calculation later. But if I want to find the least possible profit, if I want to find the least possible profit, it means I will slide it to the left since it is going lower and lower, lower profit here, and find where is the last pair it touched. Ah, so when I slide it left, okay, it seems like 2 comma 4 is the pair that give us the least possible value of profit. But we cannot take 2 comma 4 here. Why? Since 2 comma 4 is exactly the intersection between the red line and the dotted line. Dotted means we cannot accept that as one of the solution, one of the feasible area. So we cannot use this. So let's just, so this is not the last it touch. So let's just go further, which is the inside the. Okay, it seems like we have to zoom it. It seems like the last pair that it touched inside the visible area is 3, comma 4. 3 camels, 4 hippos. So yeah, this is the combination or the pairs that will give you the least possible profit, 3, comma 4 inside the visible area. So yeah, it's just for additional information. Of course, we are not trying to find which pair will give us the least possible value of profit. We want to find the greatest one. So yeah, this is the one. So let's continue how to find it by calculation. So let's find what is exactly the pair that we are looking for. Since, of course, let's just playing cynical here. We just cannot assume from the graph. I want to really know what is exactly the pair that is giving us the greatest feasible profit by using calculation. And we know that this pair is the intersection between this vertical line and this purple line. So how to find it? Let's just find that this is the intersection between C equals 11. Notice that I don't really care about the inequality since we are finding the intersections. So let's just assume that we are going deep into the line itself, so the equation. So do not use the inequality sign. So C equals 11, the vertical brown line, and the purple line, it is C plus H or H plus C equals 12, right? So this is the intersection between these two. So how to find the intersection, how to solve the system? Let's just using substitution. Okay, since we know that the C equals 11, it means finding the H is by substitute C into this. I'm sorry, into this by 11. So h plus 11 equals 12. And in the end, we know that the value of h that we're looking for is 1. So yeah, actually, our assumption is right. From the graph, we can clearly see it is 11, comma 1. But it is strengthened, it is supported by the fact that we finding the same result by calculation. So therefore, to have the greatest visible profit, Calvin Butterball must produce one hippo and 11 camels. Since one hippo and 11 camels is accepted, it's not violating all the restrictions that being given, and it is the only pair that give you the highest possible profit. So let's just find what is the profit will be. How? Just use the equation of the profit. So P equals 300C plus 200H. So you just substitute the H by 1 and the C by 11. Okay, and the total profit by producing one hippo and 11 camels is $3,500. So for the second method here, the second method, we are not using the testing line. So the difference is before the first method, we are assuming a line. We use just the profit, for example, 3,000, and then draw it, graph it, and then slide it. But the second method, since we have already done a lot of calculation in linear programming and by experience, we can conclude that the the pair that will be the solution will give us the maximum or the minimum inside the feasible region will always be the intersection. Okay, will always be the intersections of the borders. It means if we are speaking about this region, okay, and we are trying to find the maximum, the intersection candidates will be number one, two, three, and four. Okay, you have to look for the most right and the most top, the toppest candidates. Okay, so yeah, this is the candidates. It means by referring to these candidates, let's take the pairs and then put it into the profit equations, compare, and then which of these intersections will give us the largest possible profit. That is the second method. So for this one, since we have four intersections that we can consider, but again, I can directly feel it. And I mean, we can logically predict it that number four will be less than number one, the profit, right? Since four is the pair of 11 comma 0, and this one is 11 comma 1. Of course, 11 comma 1 will give us more profit than 11 comma 0. And also with this, number 2 and 3, we can be certain that 3 is less than number 2. It means that let's just consider only these two intersections, okay? Since from the first intersection, okay, we have already calculated from the first method that this is the intersection between C equals 11 and the purple line is H plus C equals 12 and the intersection is 11 comma 1. It gives us the profit 3,500. Just let us assume, let's just pretend that we don't know that this is the answer. Okay, we have to consider the second candidate, number two. Okay, number two, what is the pair of number two? Of course, we need to find it by solving the system. This is the intersection between the the horizontal blue line and the purple. So you have to remember what is the equation. So the horizontal blue line, it is the h equals 7. And the purple one is h plus c equals 12. So the intersection between these two, I will use the substitution. So yeah, the h must be 7. So by substituting it into the second equation, I will have the c equals 5. So the pair of the second candidate is 5 comma 7. Let's just put this into the profit equation. So profit equations is 300 times 5, the total camels, and 7 times 200. The profit is 2,900. It is less than 3,500. So this is not the answer. And since we don't consider other intersections, number 4 and 3, so we can conclude that this is our answer since it gives us the highest profit. So that is the second method. But of course, it seems like the second method is just easier, but it depends on the case. If we have candidates more than two, based on the restrictions that you have, for example, we have different case and the region is not like this. It's much more complicated like than this, and the candidates is more than three or four. It will take more time, I think, to find the intersections of each uh, candidates and then put it into the P and then compare. I prefer the line, the testing line, and just slide it, and then you can find directly, and you can be certain it is the pair. So yeah, it's up to you which method that you want to choose. Thank you for listening.